All right, everybody. Thanks for being patient with me with the no power situation with the videos from Monday. Well, yesterday's videos now. So what we're going to talk about today, I'm going to go through part 2 and part 3 are both pretty short. Part 3 is much shorter than part 2, even more so. So I'm going to go through and knock out both of these tonight and give you both videos. They'll just be in 2 parts. The one we're getting ready to talk about right now, part 2, is a little more calculator heavy, and we'll do a couple examples, but part 3 is pretty basic. It's pretty straightforward, and we'll start talking about these. So we're going to talk about least squares regression lines today. You learned these back in Algebra 1 or Math 1, depending on who you had, and it was you just called it a linear regression. They didn't go through least squares regression. These pictures here are talking to you about how they find it. What they want to do is they want to find the line that makes the summation of the residuals squared be the smallest it could possibly be. I don't need you to know that. You won't have to do any math with that. You're just going to mash buttons and the calculator's going to spit it out at you. But if you care about where it's coming from, that's what these 2 pictures are right here. It's showing you what they're doing for every single one of your data points. They're going to calculate the residual, they're going to square it, and they're going to make sure that line is what's giving you the smallest summation of all of those residuals squared. In the grand scheme of things, not a biggie. Just know that that's what they're doing and move on. So for this next part down here, residual plots, this is something new that you're going to have to work through. I have my window a little funky here. Hang on. There we go. Okay, so your residual plot is different than a scatter plot. So on the left, letter A, this is your scatter plot. So it's the scatter plot for your data. Ugh. Bless. Okay, we'll try that again. Alright, so that's the scatter plot for the data. And you can see the regression line going down the middle, the least squares regression line, the LSRL. And it's giving you the points, and then it's showing you with the equation. Over on the right-hand side, this is the residual plot. If you notice, the x-axis is the same for both graphs, and that's on purpose. It should be. What's different is your y-axis. So the residual plot is graphing for every single x value of your data set. It's saying what the residual was. So how far away the observed data point was from the predicted data point from the line. And so that's just a subtraction problem. They've done the subtraction problem from all of the data points and then plotted them. Again, that's not something you're going to have to do by hand. Your calculator will do that for you, and I'm going to show you in a few minutes how to do that. What we're going to look for when we're looking at a residual plot, it is kind of like our last piece of information to be able to determine, yes, this is a linear relationship, or no, it's not. It's kind of the last piece. It's the deal breaker. If it passes the residual plot test, then we're good to go. So things you want to be looking for when you're examining a residual plot. So the first thing you want to look for is your residual plot should have no obvious pattern. It should look like a hot mess. So this is an example of a residual plot with no obvious pattern. It's just dots every which way. And then the second thing you want to look for is you want to look for that your residuals, your dots, should be randomly scattered above or below. So they shouldn't all be above, they shouldn't all be below. It should be a mix. All right, the next thing you want to look at is your residuals should be small. But with a grain of salt there, hang on. So they should be small, but that needs to be relative to the data. So for example, if you look at letter B up here, if you look at your residuals, that scale goes anywhere from negative 10,000 to positive 10,000. So I don't know, I don't necessarily consider something like 8 or 9,000 to be small. But when you come over here and look at the y-axis on the scatter plot, when you look at what the data is actually talking about, that was talking about going anywhere upwards of 45,000. So compared to 45,000, 9,000 or 8,000 is on the smaller side. So you just want to make sure that your residuals aren't way bigger than your data points. And then the last thing you want to look at with this is if you do see an obvious pattern. Nope, I just realized I missed an N up there. It's not linear. And so that's the deal breaker. So if I'm squishing in the scatter plot here, or this residual plot here, this would be an example of a residual plot that has an obvious pattern. So that looks like a parabola. Everything's kind of in order. You can tell that it's going. It's not that crazy scattershot hot mess that it was in the first one. So if you see some kind of random pattern to it, that is your last and final kind of hurdle to jump to decide whether data is linear or not. Because what we talked about yesterday in the other videos, we talked about looking for your residual and if your correlation coefficient, and if your R value was close to 1 or negative 1. We also talked about just looking at your data. Is it a positive correlation? Is it a negative correlation? Or is it no correlation? So those are a little more touchy-feely, for lack of a better word. They're a little more floofy and amorphous to figure out if nebulous. That's what I'm looking for. It's a little more nebulous to decide whether something's linear or not. A residual plot is real cut and dry. You look at the plot, boom. Yes, this is either linear or no, it's not. It's a lot more obvious. Problem is, it's got like 4 more steps. So a lot of times people are like, I'm just going to find the R and move on with my life because I don't want to go through all the steps of finding my residuals. But luckily for you, we're going to find the residuals in this next part, and we can make the calculator do all of the work for us. So up at the top, I gave you your calculator steps. So the LSRL is our least squares regression line, or just linear regression. All right, and once you have your data in your scatter plot, or in your table, then you can just do menu 4, 1. Usually we've done 4, 1, 1. Now we're going to do 4, 1, 4 to pull up the linear regression. When we're getting to our residual plot, you have to do those steps first. You have to calculate your LSRL, because if you don't have a line, you can't find your residuals for it. Once you've done that, then you can just go into your scatter plot, and it will actually be an option for your y-axis that you can go tap it and click and pull it up. All right, so we're going to walk through 2 examples of these in your calculator and take a look and see what we get. All right, so for this first data set, I already have it in my Inspire. You can kind of see it in the background there. What we're going to do for each of these is we're going to look at a scatter plot and figure out if the data looks linear. Then we're going to actually do the calculation and figure out the LSRL and our R value. Then we're going to interpret our R in context, just a little more practice with that. And then we're going to look at our residual plot and decide, is this linear data or is it not? All right, so I went ahead and put the data in. You really, really, really want to label your columns, especially if you're doing a bunch of these problems at once, because you're going to have a whole bunch of context going on and your calculator, otherwise you got to dump your memory basically on your calculator each time, or pick a new spreadsheet. So I would go ahead and label them. So I did chirps for A, and then temp is for my B. All right, I want to look at my scatter plot. So to do that, I'm going to hit my little house, and then I'm going to tap the graph icon. And so it gives me this, and now I need to go in and tell it what goes on the x-axis and what goes on the y-axis. So my x-axis was chirps, and then my y-axis was temperature. All right, so we've got this scatter plot right here, and looking to me, that looks pretty linear. It looks pretty strongly positive. Data's going up to the right. It's almost in a straight line. They're pretty close. So yeah, if I was just glancing at this data, I would say yes, the data appears to be linear. All right, now to calculate our LSRL. I keep getting that one tongue-tied on that one. All right, so what we're going to do, we're going to go back to our scatter plot. So for me, that was our table, sorry. Go back to our table. All right, then I'm going to hit menu, 4, 1, 4. All right, I got to tell it what my X and Y are. So my X was chirps. My Y was temp. Everything else you can leave alone. Leave it all blank. Hit OK. And there we go. It's going to spit out all the information. So it tells us what the equation should look like. And we talked about that last video. So that would have been y hat equals a plus b times x. And then it tells us what a and b are. So it's y hat equals 37.259 plus 0.239x. So for these, I always round to 3 decimal places, but that's kind of an arbitrary decision. That's just what I've always done when I do these problems. So just be aware of that. I think usually 3 decimal places gives you enough accuracy when you're using it to actually calculate things. All right, so that's the regression equation, our LSRL, but we also need our R value. So if you notice, our calculator is giving us R squared. That's going to be important in the next video, so the next bit of notes. So just hold tight to that one for a minute. And the next thing we want to look at is we want to look at the R right below it. So here we've got our R value is, our R value is 0.996. If you remember yesterday, we talked about how your residuals were on a continuum from -1 to +1. So that is really close to +1. And that's what letter C is asking, and they're asking us to interpret it in context. So since that is really close, what we're going to go ahead and say is, that since R equals 0.996 is very close to 1, there is a strong positive relationship between chirp rate and temperature. All right, and then the very last thing they want us to do is look at that residual plot and decide. So we know it has a strong positive relationship. Does it have a linear relationship? And the residual plot is what lets us go ahead and figure that out. All right, so we need to go back to our scatter plot. All right, and now we need to change our y-axis. So where it says temp, I'm going to tap on that, and then it gives me a whole bunch of extra stuff on here. All right, so we want stat1 resid, because we just found the residual for that one. All right, and there we go. We're looking at that graph. That looks like a hot mess. Like, I see no pattern to that at all. It seems the dots are pretty evenly distributed above and below the x-axis. The residual seems small. If you look at the scale, we're anywhere from about 1.2 to just under negative 1.2. Compared to our data, that is definitely a small value. So I think we're good to go. So residual plot, shows no obvious pattern. Indicating, oops, a linear fit. So based on all of that information that we just got, part A, B, C, and D, we could say that the number of chirps per minute of the snowy tree cricket has a strong positive linear relationship to the temperature outside. So the R value gives us the strong positive, weak positive, strong negative, weak negative. The residual plot tells us yes, it's linear, or no, it's not. So those are the two steps. All right, so going ahead to number 2, we're going to do basically the exact same thing. All right, in this case, what we're talking about is we're talking about a data set. Gives the length of a radius in inches of a regular polygon with a given number of sides. All right, so I saved this one up here already, so you don't have to watch me type. All right, so we've got that one. So first thing we want to do is we want to look at that scatter plot. So we're going to tap the house. We're going to go to the graph, and now we need to adjust it. So our x-axis is number of sides, and this is where things gets a little chaotic because all of those residual options are now in here. So that's why labeling your columns was so important. So we have sides on our x-axis. On the y-axis, we want radius. And there we go. All right, so first question it's going to ask us is, does this look linear? Well, to me, that looks almost perfectly linear, just going off of the scatter plot. So for now, yes, that looks linear. All right, now we got to go through some steps to make sure our eyes aren't tricking us. All right, so we need to find our LSRL and our R value. So we're going to go back to our scatter plot. We're going to hit Menu, 4, 1, 4. And then we got to change our list. So our X was sides, our Y was radius. You can leave everything else alone. Tap OK, and there we go. You can scooch a little bit if you need to so you can see a little better. All right, so we're going to have Y hat equals 0.0995 plus 0.152x. And tapping down to our R value, we get 0.9997. All right, so for part C, it's asking us, what does that tell us about our data set? Well, that is really close to 1.9997. We are almost there. So again, that's going to indicate a strong positive relationship. All right, so part D, we've got to look at that residual plot to make our final judgment call to decide, is this really linear or is it some other form? So we're going to go back to our graph. We're going to tap the Y, and now again, got to be careful. So this was the second time we've done a regression, so it's stat 2 residual. All right, so looking at that graph, that looks completely different than the one we just looked at. The one we just looked at was a hot mess in number 1 when we looked at those residuals. In this case, I see a clear pattern. It's not quite quadratic, but it's definitely got a curve to it. So we can say that this is not linear. We don't know what it is, but we can say it does not have a linear relationship. All right, so that's pretty much it. That's as much as you will have to play with those for today, for this first homework set. I'm going to have a second video up for you very soon, talking about how to do finding the R squared that I told you we deal with that. And then we're also going to talk about standard deviation of the residuals here in a minute. All right, if you have any questions, shoot me an email. Talk to you guys later. Bye.